Hello everyone. So let us discuss today some numericals related to whatever concepts we have learned till now. That is reflection in plane and spherical mirrors. So we will be taking questions one by one today. And numerical section is what more scoring than the theoretical part. So whenever you get an option to attempt numerical problems, that is a much better way to score marks. So let us begin with the first problem. So if boy is moving towards a plane mirror with 5 centimeter per second. So what is saying that this is your plane mirror and suppose this is the object, that is the boy. Okay, this is your object. This is the distance between the mirror and the object, which is you. Obviously in plane mirror we told you that this is your image point. If this is your image point, then u is equals to v, that we know, right? So at any time, if we consider this, at any time, if suppose this object is moving with a speed, at any time we see the image will also be moving towards the mirror, because at whatever point the object is equal to that distance from the mirror, the image will be there. So that is why these two objects, that is the object and the mirror, seems to be, they will be approaching each other. So in relative velocity concept, what we know, suppose two vehicles, say suppose one with x meter per second, other with y meter per second, are approaching each other, then we call the relative velocity as, sum of these two, that is x plus y meter per second will be the relative velocity observed. So in this case also similarly, we can observe that these object and image are approaching each other. And what will be the speed? You can see that speed of image, and object, these will both be same. Both will be same because at whatever instant this object present is in front of mirror, there only the image will be forming. Suppose the object is here, the image will be here. Object is here, image will be here. So if the object is moving like this, image is also moving like this. So that is why if 5 centimeter per second, if 5 centimeter per second is the speed by which the boy is approaching the plane mirror, the image also will be moving in this direction with 5 centimeter per second. So what will be the relative velocity? It will be 5 plus 5, that is 10 centimeter per second. Understood? So this is your first question. So where we use the principle related to the plane mirror, that is the distance of object and distance of image from the mirror is both same. Okay. So let us now move to the next question. So second question is telling that two plane mirrors A and B are placed at a separation of 10 centimeter. So this distance is 10 centimeter between these two mirrors. Let us name it like AX and BY. Like BY is a mirror, AX and BY are 100 centimeter length plane mirrors. Okay. So a ray incident on the corner of mirror B. So at this point the ray is becoming incident at an angle of incidence 45 degree. Find the number of times rays is reflected from mirror A. So this is your incident ray and obviously this is your normal, right? Now let us mark these points. That suppose this is your C, this is your D, right? And these two are the normals, right? This is your normal and this is also normal. So what is happening here, and mark this point as O. So what is happening here is that incident ray is first incident on this mirror B, then it becomes reflected ray. This reflected ray becomes incident on mirror A, again the reflection occurs and this reflected ray becomes incident ray for mirror B. So like this, a reflection, multiple reflection will be observed till the end of this mirror length. Okay, so he's asking that how many times this ray will be reflected from mirror A. Okay, so we need to understand that this zigzag type of pattern will be observed with this ray. So one time it will get reflected from this mirror A, the next time it will reflect it from mirror B, then from A, then from B. So alternatively they will be reflecting like this. So what will happen? So the total half of total reflections will be from mirror A and half will be from mirror B. So what we need to find here is that suppose this is a 100 centimeter distance, we need to find after how much interval the reflection is going on. Okay, so that means this is the first point of reflection, this is the first point of reflection, then this is the second point of reflection, like this continuously, that will be third, fourth, fifth, how many up till this 100 centimeter is getting complete. So now let us now analyze. We can see that this AX and BY are parallel, right? These are parallel. So this BC is now a transversal, right? And we can say that this 45 degree, then this angle is 45 degree. Why? Because angle I is equals to angle R. So that is why we can say that this angle is 45 degree and BC is transversal. BC is transversal. This BC is transversal as I wrote. So this is now, because why transversal? Because these two are BY and AX are parallel lines, right? And also this normal, let me mark like this clearly. This normal, this is your normal, right? This is your normal. This red color, it is your normal. And this is also a normal. This one is also normal. So this is now a transversal BC. So this is cutting. So this angle and this angle is equal. So that is why this is also 45 degree. And this is now incident ray. This becomes now the normal. So this is your reflected ray. Again, this angle will be 45 degree. So these two angles are 45 degree. Now listen. What I am telling is that this angle 45, this angle 45. This angle now 90 minus 45 is this also 45. So this is what it becomes. I extended this normal, right? This also we extended, and this became 45. Since this is 90 degree, this angle is 45. This angle is 45. This angle is 90. Now this is 90, so by linear pair this is also 90, and this is 45, so by law of reflection this is also 45. Since this is 90, this is 45, this will be always 45. Why? Angle sum property of triangle. Okay, so or you can say that this is normal, this is also a normal. These two normals, this normal and this normal will be, this normal will be parallel one, so this and this will be 45 degrees. So this angle is also, so what we have found that this angle is 45 degree. Now we need to find this distance. If we are able to find this distance, we will be dividing it by we will dividing this distance with this as the your numerator, that is 100 by x. Suppose this distance is x, right? This distance is x. So we need to find this. So from trigonometry, you know that tan theta is equal to perpendicular by base. So you can see that in this, always the triangle should be right angle triangle. So you can see this triangle. Suppose this was your C and this was your O. In triangle, this is in triangle CBO. Okay, this tan 45, this be what it will be. It will be, suppose this is your theta. I am taking this as theta. So perpendicular is what? CO by BO. So what is CO? CO is nothing but this one. This is 10 centimeter. So it is 10 centimeter upon BO, you don't know. And this is tan theta. So theta is what? 45 degree. And 10 by BO. We know tan 45 degree is equals to, this is equal to 1. So BO we will be getting as 10. So what we are getting x, this distance is what? 10 centimeter. That means at every 10 centimeter, at every 10 centimeter, the reflection will be going on. And half of this reflection will be from each mirror. So that means what I can write now is, so total reflections, uh, total number of this reflection going on, yes, is what? Total distance is 100 of this mirror, and every 10 centimeter the reflection will be going on. So 10 number of reflection will be there. Now we know that half of these will be from mirror A and half of this will be from mirror B. So for mirror A, we can write 10 by 2, that is 5 reflections. So 5 reflections, that is 5 from each mirror will be there. So 5 from B mirror, 5 from A mirror. That will be the total number of times the ray is reflected from mirror A. Okay, 10 times this ray will get reflected. 10 times this ray will get, this ray in striking the mirror B, 10 times it will get reflected, and 5 from mirror A, 5 from mirror B. So the answer will be 5. Okay. Let us now see the next question. So now he's telling which of the correctly represents the graphical relation between angle of incidence and angle of reflection. We know that angle of I is equals to angle of R. That means as I is increases, R also increases. So I is directly proportional to R. Directly proportional means there is a linear relation. Linear relation means what? Is a straight line relation. The graph observed will be straight line. Okay, so a straight line graph means this is your parabolic, so curve path, this is not, cannot be the answer, this cannot also be the answer. Now straight line are these two. Now observe here that as R is increasing, okay, in this x-axis there is angle of reflection, that is R. So R is increasing, I is, what is happening to I is decreasing, the value of I is decreasing. This is point, okay, this is decreasing. So I is decreasing, so this shows your inverse relation. As R increases, I decreases, so that means this is wrong, because I must increase, R also increase. So here what is happening, you can see this graph, obviously this is the answer, because R is increasing, I is also increasing. So this is the increasing linear relationship graph, so D will be the answer. Okay, direct proportional relation is always a straight line. Let us see this question. So he's asking two mirrors A and B are placed at 90 degree. Okay, this is the 90 degree angle to each other as shown in figure. A ray of light incident on mirror A at an angle of 25 degree. So this is your angle of incidence. This is your incident ray. This is your incident ray. This incident ray, and this is your C. You can see that this is normal. Why normal? Because this is 90 degree with this surface. So this is your normal. And incident ray is making angle 25 degree with this normal. So he's asking the angle of reflection for the ray reflected towards the mirror B. Ray reflected from mirror B. Okay. So what will happen? First of all, he is asking ray reflected from mirror B. So let us first of all draw the reflected ray for this A mirror. So obviously, if we draw the reflected ray, it will be somewhat like this. Reflected ray. Okay, from mirror A. From mirror A, this is getting reflected, and this angle of incidence, right? This is equal to this. So angle I is equals to angle R, which means that this angle also will be 25 degree. Okay, now you can see that this is 90 degree. This is 90 degree. Okay, these two lines are parallel. This one normal, and this normal, and this mirror. These both are parallel, and this acts as a transversal. Okay, this acts as a transversal, and it is cutting these two parallel lines. So if this angle is 25 degree, this angle will be also 25 degree because of alternate angles. This is 25. Says this is 25 degree. Now if I draw normal to this surface, it will be somewhat like this, right? So this is 90 degree. So what will be this angle? This total angle will be what? This total angle is what? 90 degree. So this angle is what? 90 minus 25. So this is 65 degree. That means this angle, this particular angle is 65 degree. So it will be reflected like this. This is the incident ray on mirror. This is the reflected ray from mirror B. So if this is 65 degree, this will be also 65 degree. So the answer is what? 65 degree. Okay, this angle is equal to this angle equal to this angle, and this angle is also equal to this angle. So it is nothing but it reduces to geometry only. This becomes equivalent to your geometry only. Okay, so by this way you can solve this questions. Now let us move to the next question. A mirror forms an image which is 30 centimeter from an object and twice its height. Where must the mirror be situated? Okay, he is telling that mirror forms an image which is 30 centimeter from an object. That means we know that image distance is v and object distance is u. He is telling that the difference between these two, that is object distance and image distance, okay, is 30 centimeter. Okay, and he is telling that the image is twice the height its object. That means magnification is 2. It is h dash by h or minus v by u. Okay, so you can write minus v by u is equals to 2, or you can write v is equals to minus 2u. This is your first equation. This is second equation. So from these two, you can write from 1 and 2. One can be written as, placing the value of v in the first equation, we get minus 2u minus u is equals to 30. So that means minus 3u is equals to 30, or u is equals to minus 10 centimeter. This means that he is asking where must the mirror be situated. So you can answer by this, that 10 centimeter away from object. Right. Now, what is the radius of curvature? Now let us move on to the next part, that is radius of curvature. So we know that radius of curvature is what? R is equals to 2f. So we need to find this focal length. Then we will be able to find out. So we know that 1 by f is equals to 1 by v plus 1 by u. This is your mirror formula. And you know the value of u is minus 10 centimeter. And v we know minus 2u. So this is nothing but minus 2 into minus 10. So what is v? V is equals to 20 centimeter. So I will put the value of v and u in this formula. So 1 by f I will be getting it as 1 by 20 and u will be minus 1 by 10. So this is your focal length. So what it will be? It will be 10 minus 20 by 200. So this is nothing but minus 10 by 200. So 1 by f is your minus 1 by 20, or f you can write it as minus 20 centimeter. See, now radius of curvature is what? 2f. So it is 2 into focal length. Since we will be concerned about magnitude and radius of curvature, so it will be 40. Now, is the mirror convex or concave? So this you can easily find out. How? Because by magnification. How by magnification? Let me tell you. You can already see. I told you that whenever there is an enlarged case, the image is twice as its height. M is 2. This means enlarged. And enlarged case is possible only in concave. By this only, because convex will form, convex mirror, I told you that it forms always a diminished image. So always m is less than 1 in convex mirror, but here the magnification is 2. So 2 means what? 2 means what? The image is enlarged. And you can also see that is the plus sign. So plus sign means virtual image. Okay, virtual image, enlarged image, and see the focal length. It is 20 centimeter. It is like this. Suppose this is your concave mirror, right? This is your pole. and this is your, let us mark your principal axis also. This is your principal axis. So F is, this is your F, and this is 20 centimeter. Negative focal length also. This is also another landmark, because I told you a focal length is negative always in concave mirror only. So since focal length is minus 20, and where is was the object? We find that the U was minus 10 centimeter. So U is here. That means object was somewhere here, less than this focal length, 10 centimeter distance. So when between F and V an enlarged image is bound to be formed, virtual enlarged image will be formed behind the mirror. This is the only case of concave mirror where an virtual image is formed. So this is how you can know what mirror it is. Okay, by considering this, many pointers are there. You can see the sign of this focal length. Negative focal length means concave mirror only. Also, enlarged case. So image is enlarged only when it is a concave mirror. Okay. So that is the case, and when an enlarged image is formed, it means it will be concave mirror. So this is your solution to this problem. So this was a really good problem to build concepts. Let us move to the next question. A security mirror 5 meter from certain items displayed in the shop produces 1/10 magnification. So what is the meaning of 1/10 magnification? So magnification is 1/10. Or we know that m is equals to minus v by u, which is 1 by 10. So I can write v is equals to minus u by 10, right? And what is u? U is given to u as 5 meter. So always whatever mirror you will take as u as minus 5 meter, negative sign, because if this is the convex mirror, security mirror, always a security mirror, this is this type of mirror will be convex mirror. Okay, and a diminished image is formed. 1/10 means this is a diminished image. M is now less than 1, but we can't tell directly it is a convex mirror. Why? Because in concave mirror both diminished and enlarged images can be observed. In convex always diminished image is formed, but in concave case also sometimes diminished image is formed when the object is behind C, beyond C, or in infinity case we observe diminished image in concave mirror. So we can't comment till now. So we will solve further. Okay, so you know u is this. Okay, minus 5. So v is what? You can write v equal to minus u. That means minus of minus 5 by 2 by 10. Sorry. So this is your 1 by 2 meter. This is your v. Okay, and now you can find the focal length. 1 by f equal to 1 by v plus 1 by u. So if I use this formula, 1 by f is equals to 1 by v is what? 1 by 2 upon 1 by 2. So that becomes 2, and plus 1 by u. 1 by u is what? Minus by 1 by 5. So this is what? 10 minus 1 upon 5. So this is 9 by 5. So what is focal length? It will be, this was 1 by f, so it is 5 by 9 meter. Observe that the sign is what? Positive. It is positive, and positive, I told you, positive f means a convex mirror. So this type of mirror is what? Convex mirror. And what is the radius of curvature? We know that radius of curvature is what? 2f is equals to r. So 2f is what? 2 into 5 by 9. This is 10 by 9 meter. This is your answer. Right? This is how you solve. A concave mirror produces 3 times magnified real image of an object placed at 10 centimeter in front of it. So where is the image located? So now what he is telling that there is a concave mirror. Concave mirror, he is mentioning that it is a concave mirror and it is 3 times magnified real image of an object. Real image, see, real image of an object placed at 10 centimeter. So what do you understand from this? That is, your image distance is equal to minus 10 centimeter, right? And what is magnification? Magnification is 3 times magnified. So it is 3. But now please pay attention to this. Real image. Real image meaning what? Real image means that the sign is negative. The magnification is negative when it is a real image. Also, we know that m is equals to minus v by u, which is equals to minus 3, right? So v by u is equals to 3. So we can write that, we can put the value of u from here. So v upon minus 10 is equals to 3. So this implies that v is equals to minus 30 centimeters. So where are you getting? Where the image located? It is located as v equal to minus 30. And v is equal to minus 30 means what? It is like this. Suppose this is your concave mirror, right? This is your concave mirror and this is your pole. And if you want to have the locate the mark the image distance, so if this is say 10 centimeter, then v is also on the same side, and the real image means real and inverted image. So it is like that. Okay, something like this. So this is the case. It is on the same side of the mirror. V is also negative. So this is what you need to understand. Next question. The focal length of a concave mirror depends on the distance of the object from the mirror, the distance of image from the mirror, the radius of curvature of mirror, or none of these. What should be the answer? Answer is C. Why radius of curvature? Let me tell you. You will see that you can tell that 1 by f equal to 1 by v plus 1 by u. You can say that okay, focal length is depending on this image distance also and object distance also. No, focal length does not depends on image distance. Okay, it does not depends on object distance. It is a constructional feature. Okay, how? I told you that what is the definition of a spherical mirror? A spherical mirror is what? It is made out from a sphere. So if you are taking a sphere and taking a part of it, so once you are making this mirror, whether it be a convex mirror or concave mirror, what you do? You cut, first of all, you cut this from a spherical, hollow spherical mirror, hollow spherical surface. Okay, from this hollow spherical, you will be cutting this, and for that sphere, the radius of curvature will be fixed. This is your radius of curvature. So if radius of curvature is fixed, that means what is 2f equals to r, f equal to r by 2. So by the time you make this convex or concave mirror, by construction, the value of r is fixed. That means value of f is fixed. So f is dependent on the construction. Okay, it depends on the radius of curvature, because radius of the curvature is will be fixed for a sphere from which you are making the spherical mirror. This relation tells you that if you vary the object distance, if you change this u, how the v will be getting affected, and these depends on this focal length. Okay, focal length will be fixed for every mirror. Once you set a, once you call, hey, this is the mirror which we are using, so f is fixed. Now f is fixed. Now you will vary u, and according to that, this mirror, according to this focal length and this object distance, this image distance will be. So that is why focal length is a constructional feature, and it will be defined at the time of construction of the mirror. And that is why at the construction time, that is means the sphere, it will depend on the sphere, and the radius of curvature is the one which is exclusive to each sphere out of which you are making the mirror. So that is why this radius of curvature will govern the focal length. That means indirectly that at the time of construction, that is the time where the focal length is get defined, and that is becomes a constant thereafter. That is why it is, we can say that it depends only on the radius of curvature, and which is fixed for every sphere. Okay, for different sphere we have different sphere radius of curvature, and we have different focal length. So this is the meaning. Okay, next question. The magnitude of focal length of a concave mirror is f. An object is placed at a distance x from the focus and forms a real image. The magnification is, okay, an object is placed at a distance x from the focus. So he's telling a concave mirror is there, right? This is your concave mirror and this is your pole. So if this is your principal axis, he is telling that the object is placed, suppose this is your f point, right? And this is your focal length, this is your focal length, and distance x from the focus. That means from this focus there is another distance x. Okay, so object distance is like this, x and f. Okay, so u is what? X plus f. Okay, so first of all, uh, let us write the relation between magnification and object distance. So we know that magnification is what? Minus v by u, right? And 1 by f is equals to 1 by v plus 1 by u. So what I do, we want to find a relation between we want to find a relation between u and f, because these are the options. X is nothing but this object distance only, so uh, is a part of object distance only, so u and f we will finding the relation. So what we will do, we can write like this, we can substitute let us say uh, u and v we can write from here, right? So what we can write, 1 by f is equals to u plus f, u plus v by uv, right? And from here I can write that, what I can write, I can write v is equals to, I can substitute from here. Okay, I can substitute from here. uh, let me substitute it from here only. So I can write this, 1 by v is equals to 1 by f minus 1 by u. So this will be 1 by v is equals to what? U minus f by uf. Okay, or you can write like this, v is equals to uf by u minus f, right? And what is asking? He is asking magnification. So magnification is minus v by u. So m is equals to what? V, I can use this value. So it will be minus uf upon u minus f, and upon denominator is u, right? So now I will write this here. I can write now here. So this is what we are getting. So that means m is equals to minus uf upon u minus f to 1 by u. This gets cancelled out. So you are left with minus f upon u minus f. And we know what? We know what? U is what? X plus f. So if I put it here, minus f upon x plus f minus f. So this f gets cancelled out. We are left with minus f by x. Okay, so what will be the answer? Answer will be minus f by x, right? So this was the case. So anywhere till now we haven't put any like we don't have used any sign convention. Automatically we will put in this formula, then we will get the right signs. Okay, the sign will we will getting right. Till now we are calculating by just the formulas only. We are not touching the signs. Now you will put the focal length and this x with proper sign convention. Then you will be getting the correct result. Okay, so this is the point. Okay, this question. An object is placed at a distance of 20 centimeter from a convex mirror. So he's telling that suppose this is your convex mirror, this is your pole. He's telling that the radius of curvature of this focal of this lens is 40 centimeters. So what is focal length? Focal length is 40 by 2. It is 20 centimeter. So this is the point of F, 20 centimeter, right? And where is putting the object? So U is also what? U is minus 20 centimeter. Here he is putting the object, right? This is U is also, this is U also. Okay. Now, obviously, I will mark the focus point here. So this will be your, let us say 20 centimeter. Now focal length is positive in case of a convex mirror, right? Now at what distance the object should be, a plane mirror be placed so that the images due to the convex mirror and the plane mirror are in the same. What he is asking is that if now first of all we find where the image will be formed here, okay, in convex mirror. So in convex mirror case, okay, the plane mirror will come in the later part. First of all, let us see the convex mirror. We know that 1 by f is equals to 1 by v plus 1 by u. So 1 by f is what? 20. I am putting with the proper sign convention because this is a convex mirror. So that is why I am taking focal length as positive. And 1 by v, we don't know. And 1 by u is what? Minus 20. So minus 1 by 20. So what is v? V is what? 1 by v is what? 1 by 20 plus 1 by 20. That means v will be come out to be 10 centimeter. So first of all, where the image is forming, it is forming 10 centimeters. Somewhere here the image is forming. Okay, like this. Suppose this is your, like it will be something like this. This will be your reflected ray, and this will be coming, and like this. Somewhere here the image is forming. Okay. Now this distance is what? 10 centimeter. This distance is what? 10 centimeter. Let me draw it clearly for you. One second. This was your convex mirror, right? This was your pole. This is your principal axis. And I told you that this is going to be your 20 centimeter. Here the object is placed, right? Here the object is placed. And at this object, the focal length of this mirror is also somewhat like this, 20 centimeter. This is f point 20 centimeter. And the image is forming at what? We have found this point 10 centimeters somewhere here. 10. Somewhere here the image will be formed. Obviously it will be diminished and erect also and virtual. Okay. Now is asking at what distance from the object plane mirror should be placed so that the images due to the convex mirror and plane mirror are in the same plane. So that means the image point is here. Okay, so here only the image due to plane mirror should be formed. Okay, so object distance is this. Okay, so what about this total distance? This is 20 centimeter and this is 10 centimeter. What is this total distance? This is 30 centimeter, right? This is 30 centimeter. Now he's asking where should I place a plane mirror? Where should I place a plane mirror so that image will be here only? So we know that the u is equal to v in plane mirror. In plane mirror, we know u is equal to v. That means we need to place a mirror in such a way in the midpoint of this place, midpoint of this distance, so that the image will be formed here. So if I place the mirror here, okay, so if I, this is 30 centimeter. So 30 by 2 is what? 15 centimeter. So at 15 centimeter from this object, suppose here I will be placing the plane mirror. Here I will be placing the plane mirror. So what will happen? This is 15 centimeter and this left distance 30 minus 15, this will be 15 centimeter. So now the image will be here at this point. So they will be in the same plane. So since u is equals to v and this total distance is 30, so at the midpoint of this, that means at 30 by 2, that is at 15 centimeter. At 15 centimeter, we will be placing the plane mirror so that the image due to this plane mirror and the convex mirror, which was here, the convex mirror image was here. So the plane mirror image will be on this plane only. So that is how we will be putting this mirror 15 centimeter away from the object so that the image will be from 15 centimeter further back from this, which is the point of image for convex mirror also, which is the plane of image correctly for this convex mirror also. So that is how we find this. So these were some of the questions related to the reflection part. More problems can be solved and you can practice by yourselves. So this was all about your reflection part of this light chapter. So in the next class, we will be beginning with the refraction part, that is the bending of light we will be seeing, and we will be seeing the different phenomena and different how the bending of light occurs depending on what type of medium. There will be two kinds of medium and the light will be bending accordingly. So that we will be seeing in the next chapter, next class, sorry. So let us wind up for this class. So let us meet in the next class. Thank you.